Okay, Unit 6, we're going to start with 6.1, polynomial functions. So some definitions to know. Scatter plot is a set of points on a grid used to visualize a relationship or possible trend in data. So here's an example of a scatter plot. Right here, you can see all these points are representing the data, and it is connected in a relationship. You can see that it's possibly forming a positive linear relationship with each other. Polynomial function is a function that contains only the operations of multiplication and addition with real numbered exponents and two variables. A turning point is any point where the graph of a function changes from increasing to decreasing or the other way around. And the end behavior is the description of the shape of the graph from left to right on a coordinate plane. Okay, so let's talk about some of these polynomial functions. So first of all, a degree is the highest exponent you would see. So on this one, the variable x has an exponent of 1, so it is a first degree. And it makes a linear shape, so a line. The next would be an exponent of 2 on the variable, so this is a second degree, and it's called a quadratic, and its shape is a parabola. The next would be an exponent, highest exponent of 3, cubic, and its shape would be an n. Here, the highest exponent I see is a 4. Okay, so it is a quartic, and its shape is a W. And the last is a quintic. It has the highest exponent of 5, and its shape is kind of like an N with an extra bump in it. Okay, please don't get tricked with degrees. So if you see something like this, that would have a degree of 5. Okay, it's not necessarily the first, but it's the one that has the highest. Okay, now we'll look at some of the characteristics. So on a linear function, the number of turning points would be 0. It doesn't ever change direction. It would have one possible x-intercept, and its end behavior would go in opposite directions. Okay, quadratic, number of turning points would be 1. So here you can see it goes decreasing and then increasing. X-intercepts, it could possibly have 2. And its end behavior would be in the same direction. So either both going to infinity, or it could both be going to negative infinity. Cubic, it could turn in 2 places, and it could have 3 x-intercepts. Its end behavior will always go in the opposite direction. So it'll either go from negative infinity and then it would go to infinity, or it could look the other way around where it would go infinity and then towards negative infinity. Quartic, it could have 1, 2, 3 possible turning points, and it could possibly have 4 x-intercepts. Its ends are in the same, so it could either both go infinity or both go negative infinity. And a quintic could have 4 turning points, and it could possibly have 5 x-intercepts. Okay, it doesn't mean that it has, this one doesn't, but it could possibly have up to 5, no more than 5. And its end behaviors are opposite. So it could go either like this or like that. Okay, so you can see that when your degrees, so this is a first degree, third degree, fifth degree, when they're an odd number of degrees, you're opposite. When the degrees are even, you'd go in the same. Okay, and then just a reminder that if you have a constant, it's because you have a degree of 0. So x to the 0 is really 1, which means that's just y equals 5. And if you graph that, it would look like this. Just a horizontal line. Because y is always 5.